I'm going to talk about Boolean logic in App Inventor and give you a little background on how it works with some examples. Um, Basically, what you have are two conditions whenever you have to do a test in App Inventor, and those conditions will evaluate to either true or false. An example of if you have an if then else block and you have a true block plugged into it, when you do the test, it goes to the then branch, the then part. So whatever you have here will be evaluated. If a false block would be attached, it would go to the else branch. So that's how those two blocks work. They're opposites. Now here's an example. If it's we're using a variable and a local variable assigned to true, time for breakfast. If time for breakfast, and that's true, then cook some eggs. So cook some eggs is displayed with the do it. So that's what would be expected there. If time for breakfast is false, then instead it would display go back to bed when you evaluate this. Now we also have a logical operator. It's a unary operator. It requires only one argument, the not block. So with the not block, not false, it gives you a true result, and not true gives you a false result. Sometimes you need to do this depending on the wording of your condition. We'll see that later on. And here are some simple examples. If is weekend is false, so it's a weekday. If not is weekend, then go fishing, else go to work. But is weekend is false, so not false becomes true, so go fishing is the result. Is weekend is true here, so if not is weekend and is weekend is true, so not true gives you a false result, so that means that the else part is executed, so we need to go to work. Looking at numbers, simple equal, numeric equal, 4 equals 4, that's true. 4 equals 7, that's false. 4 is not equal to 3, that's true. 4 is not equal to 4, that is false. 4 is less than 7, that is true. 7 is less than 4, that is false. 4 is greater than 3, true. 4 is greater than 7, false. 4 is less than or equal to 4, that is true. 4 is not less than 4, but 4 is equal to 4. 7 is less than or equal to 4, that is false, because 7 is neither less than nor equal to 4. 7 is greater than or equal to 3, that is true. 2 is greater than or equal to 6, that is false. 0, 1, 2, 3 in a text block is equal to 1, 2, 3. That is true. And the reason is because when text blocks are evaluating a math expression like this, then, and this is a math equal block, then it evaluates that as 1, 2, 3 on this side, the number 1, 2, 3, and 1, 2, 3 on this side, compares those and says they're true. If you want to have a direct comparison character to character, you use compare text. So 0, 1, 2, 3 text equals 1, 2, 3 text. is false because you have a leading 0, and that is a different character from the first character in 1, 2, 3. Again, compare text. This is the text equal comparison. Capital ABC equals capital ABC, yes. What about capital ABC equals lowercase abc? That's false because these two characters, uppercase A and lowercase a, are different. In the ASCII character set, the capital A comes before the lowercase a, so it's considered to be less than the value of the lowercase a. So these are not equal. Comparing inequalities between text values, Jones is less than Smith. That would be what would be expected. But lowercase banjo is less than uppercase xylophone is not true because of this sequence, uppercases are considered less than lower cases. Banjo would occur after, or rather the B, lowercase b, would occur after the uppercase X in this sequence. So it doesn't need to check beyond that to know that this is not true. Jones is greater than Carpenter. That is true. It's alphabetical order. Higgins in uppercase is greater than Henry in lowercase. Well, the uppercase H's are the same, and uppercase I is the next character and lowercase e. And uppercase I is less than lowercase e in the ASCII sequence. So that makes this false. Now what we can do is when we don't know what case the input is in, and we have to test values, but the spelling is the same, we can use upcase or downcase. In this case we're using upcase. ABC equals upcase ABC with mixed case. So upcase forces both of these to uppercase, and that's what makes this comparison true. Here we're using variables. Total is set to 21, and then we say this is a condition or a logic expression, and we're asking, is total equal to 21? And that is true. Here total is set to 21, and we are asking, is total equal to 52? And that is false. Note that this is not an assignment like in basic programming languages or some other programming languages where you would be assigning the value 21 to total. This is just comparing these two values in App Inventor. Now total is 21, and we're asking, is it true that total is not equal to 52? Yes, that's true. And here total is 21, and we're saying, is it true that total is not equal to 21? No, that's false. Here total is 21, and we're saying, is total less than 52? That is true. Here total is 52, we're asking, is total less than 21? 52, is 52 less than 21? No, that's false. Here we are assigning the text value Smith to name, and we're asking, is comparing these two text values, is Smith equal to Smith? That is true. And here uppercase Smith is compared to uppercase Jones, and they are not equal, so the result is false. Here name contains Smith. Is Smith greater than Jones? That is true, alphabetical order. Here we're asking, is Smith less than Jones? That is false. Now we're going to look at the AND and OR logic blocks, which each take two values. And the truth table for these are, for the AND block, both values must be true for the whole condition to be true. And here's the first example. If this side is true and that side is true, then the result is true. If this side is true and the right side is false, the result is false. If left is false and right is true, the result is false. If left is false and right is false, the result is false. So the only way this will evaluate to true is if both sides are true. There are some examples using AND. We want to make pancakes, and we're asking, and we're setting these two values that we have eggs and we have flour. Those are logical, true. And the question is, if we have eggs and we have flour, then let's make pancakes. And that's what the result is here. Now this is an example using the OR block. For the OR block, either the left side or the right side must be true for the whole condition to be true. Or that means that both can be true, but at least one must be true. So with this example, work experience with some XYZ software or device, that is true. The person has experience and the person has studied. So the question is, if the person has work experience or the person has studied, either one of those would be acceptable, then they earn a higher salary. Otherwise, they get a standard wage. So the result from this is they earn a standard wage. They get a higher salary because both of these are true and at least one needs to be true. If we set one to false and then evaluate this again, they still earn a higher salary. However, if both are set to false, they earn a standard wage. That's because they neither had any work experience with the product and they didn't study the product in school. So that means that the else part is executed. Let's go back and look at we'll set these two different values. We know that we can make pancakes if we have eggs and flour, but what if we are missing one of the ingredients? If we're missing eggs, no pancakes today. The same situation would happen if you were missing flour, but we had eggs, because we need both eggs and flour to make our pancakes. And of course, if they were both false, we didn't have eggs or flour, then we couldn't make pancakes. So that shows you how that works. And and or work a little bit differently. Okay, and that's, we'll just go through these. Let's make pancakes. Okay, this one is a little different in that we have eggs and we have flour, but the question is, if it's not the case that we have eggs and flour, then no pancakes today. So that makes it a little bit different in trying to evaluate what this means. So you can look at the inside and find out if that is true. Do we have eggs? Yes. Do we have flour? Yes. Then not true is false. So if this is false, then it goes to let's make pancakes. So that's just a different way of viewing the logic. And here's another use of the not operator with the or block. Okay, here we have eggs and we have flour, and we're asking the question, if we don't have eggs or we don't have flour, then no pancakes today. So not true, because we have true, we do have eggs. Not true is false, or not true because we have flour, which is false. So we have false or false. Well, false or false means false, so that means we would have no pancakes today if this were false and this were false. So it would go to the then part. But since that is the false statement, it drops to the else part. Let's make pancakes. Okay, here we are looking at an or condition, and then it's negated with the not. So it's true that we have work experience, and it's true that we've studied. So this condition is true. Not true is false. So what should display is earn a higher salary. Okay. If we set either of these things to false, it should still display earn a higher salary. Okay. The only reason it would not display earn a higher salary is if the person has not studied or has no work experience. So earn a standard wage. And here we're looking at if the person has not had work experience, but this is true, so not true is false, and here they have studied, not true is false, so we have false and false. If either side is false, the whole condition is, or statement is false. So that means that it would not display earn a standard wage, but rather earn a higher salary. So that is what we would expect. And what we've been looking at here is De Morgan's laws or theorems that say you can express negated conditions in different ways, and the result is the same. Now we're using if then else blocks which return a value, and we're comparing is 4 equal to 4, and that is true, so then is executed, they are equal. Here we're asking is 4 equal to 7, that's false, so they are not equal. If 0.5 is not equal to 0.25, then it should display they are not equal. If 0.5 is not equal to 0.25, or rather if 0.25 is not equal to 0.25, then it would display they are not equal, but they are equal. So that's why that is displayed. If 4 is less than 7, then the left number is less than the right number. If 3.5 is less than 3.25, is that true or false? That is false. So that means left number is not less than right number. If compare text Smith equals Smith, they're both the same, and it should say they are equal. If compare text Smith is equal to Smythe, but that is false, so they are not equal. If compare text downcase Smith is equal to lowercase Smith, then they are equal, because downcase makes this uppercase s lowercase, so then they're exactly the same when they're compared. So that's true. And here uppercase Smith equals lowercase Smith, or capitalized Smith equals lowercase Smith, and they are not equal because the uppercase and lowercase s are not the same. Here we have Betty is less than Timmy, and that is true. The left string is less than the right string. Here we have Betty is greater than Timmy, and that is false because the left string is not less than the right string. And here are some examples with variables. Cash on hand is 75, and the question is, if cash on hand is greater than or equal to $62.50, the cost of the bicycle, or this might be euros in your country, or some other currency, then buy a bicycle, else no bicycle today. So this is, since our cash on hand is greater than $62.50, we can buy a bicycle. But if our cash on hand is $50.37 and we need $62.50 in order to buy the bicycle, then the answer would be no bicycle today. Now we can combine that with cash and a credit card. If cash on hand is 20 in your currency, or you have a credit card, and in this case we do have a credit card, the first test is cash on hand greater than or equal to $62.50? No, that's false. Do we have a credit card? Yes. So if either of these is true, then the whole condition is true, so we can buy a bicycle. On the other hand, if we don't have enough cash, $37.80, and we haven't brought our credit card, then no bicycle today. Okay, here we have a child that wants to ride on the Carnival ride, and if that child is taller than 48 inches and they have a ticket to ride, and both of those things must be true in order for the child to ride, then they can ride the Carnival ride. If either of these is false, the child is either not tall enough or the child has no ticket, then the result will be no Carnival ride today. And here we have the opposite situation. The child is tall enough, but they don't have a ride ticket, so no Carnival ride today. And here we've assigned true to the child has taken MMR vaccinations and they are 4 years of age. So if both of those conditions are true, then that child can start pre-K. However, this is the question being asked here is if it's not the case that these both are true, then the child cannot start pre-K. So this is true, and they are 4 years of age. They have taken the vaccinations, so that is true. Not true is false. So if false, then child cannot start pre-K. But since both of these things are true, it drops to the else part. Child can start pre-K. So that's how that one works. And then in the last example, the child has not taken their MMR vaccinations, and they are the correct age to enter pre-K. So this would be false, this would be true, false and true is false, not false is true. So that would go to the then part, child cannot start pre-K. So that's pretty much it. That's the basics. Thanks for watching.